Section 5.1, Polynomial Functions and Models. The first thing we're going to do in this section is talk about what a polynomial function is. And actually, we've been using polynomial functions this entire semester. We just haven't been calling them that. Okay, so under the first bullet point, there's a very mathematical definition of what a polynomial function is. So I'll read through it and then I'll try to translate it for you. Okay, so it says a polynomial function in the variable x is a function of the form f of x is equal to an times x to the nth power plus a of n minus 1 times x to the n minus 1 power all the way down to plus a1 times x plus a0. Okay, and then it says there's a description here of what the a's mean. So an minus 1, all the way to a1 and a0 are just constants. So if it's a constant, that means they're just numbers. And they are called the coefficients of the polynomial. Okay, so that's a lot to take in. It's very mathematical. Okay, so let's look at this thing in the box. Okay, they say this is what a polynomial is. Okay, so if we examine this, they tell us what the an minus 1, a1, a0 are. They're just numbers. Okay, so you've got a number here, a number here, a number here. Each of these numbers are multiplied by a power of x. So an, which is a number, is multiplied by x to the nth power, and then the number an minus 1 is multiplied by x to the n minus 1 power, and then dot dot dot, which means there's similar stuff in between the dot dot dot. That's what the dot 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 is. There's stuff in between. Eventually we get to a1, which is a number, times x to the first power, okay, plus a0, okay, which is just a number. Okay, so what's going on here is we are adding or subtracting powers of x. Okay, so those powers of x can have numbers in front of them. So like I said, we're adding or subtracting powers of x or just numbers, because remember, a0 is just a number. Okay, that is what a polynomial is. Okay, so I'm going to come down here. There's still a lot of terminology associated with polynomials, but I'm going to try to translate what this box just told us. How do we need to think about a polynomial in everyday language? What's going on is we are adding or subtracting powers of x or just plain numbers. Okay, so I'm going to make up a polynomial. Okay, and you can see it'll look better because it won't be as abstract. Okay, and then using that example, we're going to go through all the different terms associated with polynomial functions. Okay, so let me make one up. Okay, so let's say f of x is equal to negative 16 x to the 5th minus 4x cubed plus 2x squared plus 17. Okay, this is my polynomial. Okay, if you look at each of the pieces, okay, and when I'm saying pieces, there's 4 pieces here. Okay, each piece is basically a number times a power of x, or just a number, like the 17 is just a number, and we're adding or subtracting these guys. Okay, so that is what a polynomial is. Okay, so looking at this particular polynomial that I've made up, I am going to go through all the definitions associated with polynomials. Okay, and that's in these next set of bullet points. You see words like coefficient, degree, terms, leading term, leading coefficient, standard form. Okay, so I'm going to explain what each of those means, using this particular polynomial. Okay. All right, the first word we just encountered were coefficients. Okay, the coefficients of the polynomial, okay, those are the numbers in front of the x's. So negative 16 is a coefficient, negative 4 is a coefficient, positive 2 is a coefficient, and actually 17 is considered a coefficient. So it's just all the numbers. Okay. All right, next, degree. That's really important. Degree of a polynomial is super important, so make sure you know this one. Okay, it says the integer n is greater than or equal to 0. So it's talking about the n value. Okay, the degree of the polynomial is the highest power of x in the whole thing. Okay, that's what you need to know. The degree of your polynomial is the highest power of x in the entire thing. Okay, so if I come over to this polynomial, the highest power of x that I see in the whole thing is 5 right here, x to the 5th. Okay, highest power of x is 5. So this is a degree 5 polynomial. Okay, all right, next, terms. Okay, the terms of a polynomial are the pieces separated by addition and subtraction. Okay, so what we need to know here, terms are the pieces separated by addition and subtraction. Okay, so if we go over to my polynomial, okay, there are 4 terms, exactly what I underlined initially. Okay, the pieces broken up by addition and subtraction. Okay, one term is negative 16x to the 5th. Another one is negative 4x cubed. And then positive 2x squared is a term. And your last term is positive 17. Okay, these are the 4 pieces that make up the polynomial. Okay, these are called the terms. All right, specifically, we can talk about the leading term and the constant term, as well as something called a leading coefficient. Okay, so let's read the next sentence here. Okay, so it says, if an is not equal to 0, it gets all mathy on you again, so don't worry about that. Leading term, let me just go ahead and tell you what the leading term is. Okay, the leading term here, and I'll just write it right here. Leading term is the term with the highest power of x. Okay, so we know we have 4 terms already, negative 16x to the 5th, negative 4x cubed, 2x squared, and 17. So the one with the highest power of x is the leading term, and that's going to be negative 16x to the 5th. Okay, so the leading term here is negative 16x to the 5th. Okay, all right, then there's something called a leading coefficient. Okay, the leading coefficient is the number in front of the highest power of x. Okay, so we know the highest power of x in our polynomial is x to the 5th. Okay, so the leading term, you know, that's the piece that has the highest power of x. In front of the x to the 5th is negative 16. So that's the leading coefficient. Okay, so the leading coefficient is negative 16. Okay, lots of vocabulary here. All right, one more in terms of term, no pun intended. There's a constant term. Okay, constant term is the term that doesn't have an x. Okay, so if you look at this, out of the 4 terms, the 17 is just a number. Okay, so the constant term here is going to be 17. Okay, so the constant term is 17. Okay, no x. Okay, or no visible x, let's say. Okay, all right. The last thing we need to talk about, okay, so let me highlight these guys so you don't forget about them. Make sure you know what leading term is, what leading coefficient is, and then constant term. And the last thing we're going to talk about is something called standard form. You always want to make sure your polynomial is written in standard form. And all that means is that the polynomial is written with descending powers of x and simplified coefficients. Okay, so notice if you go from left to right, your powers of x descend. You have x to the 5th, then x to the 3rd, then x squared, and then you have the term that's just a number. Okay, so you have descending powers of x. The powers of x go down from left to right. If you are given a polynomial that is not in standard form, you may be asked to rearrange it and put it in standard form. Okay, it's easier to read that way. Okay. All right, so that was some of the vocabulary associated with polynomials. You'll hear that again and again in this section. So let's go back to the definition of polynomial. So I told you the best way to think about a polynomial is that you're adding or subtracting powers of x or just plain numbers. Okay, so the example I made up here fits that bill. You're just adding or subtracting powers of x or just plain numbers like the 17. Okay, I want to take a minute to tell you some of the things that you will not see in a polynomial. Okay, and I will give you I will give you examples of functions that are not polynomials as we build this list. All right, the first thing you will not see in a polynomial, okay, you will not see negative powers of x. Okay, so for example, if I gave you the function x to the negative 1, okay, that's a power of x, but it's a negative power of x. So it is not considered a polynomial. Okay, so this is not a polynomial. Okay, so no negative powers of x. Okay, the next thing you will not see fractions with x in the denominator. So for example, if I gave you the function 1 over x, it's a fraction and x is in the denominator, so this is not considered a polynomial. Okay, now let me add to this. Okay, let me go down here. Say I had this function. Let's see, x plus 5 divided by 2. Okay, this is a fraction, but the x is in the numerator. There is no x in the denominator. So in this situation, this is a polynomial. Okay, so keep that in mind. If you have a fraction, you have to have x's in the numerator, but not in the denominator. Okay, all right. Another thing you will not see in a polynomial, okay, you will not see radicals. Okay, so you won't see things like the square root of x or the cubed root of x or the fourth root of x cubed. Okay, you will not see radicals at all in polynomials. Okay, so these guys are not polynomials. Okay, another thing you won't see fractional exponents. So if I said, look at the function x to the 1/2 power. Okay, yeah, it's a power of x, but it's a fractional power of x. Okay, and actually x to the 1/2, we'll talk about this later in the semester, x to the 1/2 is the same thing as the square root of x. Okay, x to the 1/3 is the same thing as cubed root of x. Okay, so we can't have things like this. We can't have radicals because and we can't have fractional exponents because they are the same as radicals. Okay, so something like this, or let me make up another one. If we had, let's see, x to the 3/5 power. Okay, these guys are not polynomials. And then I'll mention one more thing you won't see in a polynomial, and that is absolute value. Okay, so our old friend from section 3.4, that basic function, absolute value of x, it is not considered to be a polynomial. Okay, so this is not a polynomial. Okay, so what you need to remember going forward, because we're going to be working with polynomials, and then later in the semester we'll look at things that are not polynomials. You need to be adding or subtracting powers of x or just plain numbers. Things you will not see in a polynomial. You will not see negative powers of x. Fractions with x in the denominator. You won't see radicals. You won't see fractional exponents. And you will not see any instance of absolute value.